Hi there, welcome to your lesson on linear sequences. This is definitely a big idea because it really connects what you know already about linear functions or just linear equations with sequences. So let's take some notes. Please use the page you've been provided with. We're going to begin here. All right, so in these two sequences here, they are both linear because that's the title here. It says find the values of the first 5 terms. So we're going to write them here in the sequence row. Then it says find the first difference. And the first difference is when we basically look at two terms in a sequence and we try to find out what is the difference between them, that's called the first difference. We'll do that right away. And then we're going to plot the points after and notice the relationship. So first of all, why are these called linear sequences? Or linear sequences, you can see it from the explicit formula. It basically resembles this equation, which you know very well, y equals mx plus b. That is the equation of a line. Notice that this sequence matches that. We have m, which is the slope, so this number here is the slope, and b, which is a y-intercept on a graph of a line, is this number here. So this has a linear form. Let's figure out what the sequence is. Let's look for u1 first, the first term right here. u1 is going to be found like this, right? We replace n with 1. We want u1, which is the first term. And if n is 1, then we replace this with 1, and we have 5 times 1. So 5 times 1 is 5, minus 2 is 3. So u1 must be 3. So our first term in this sequence right here is 3. Now do the same thing just in your head. Replace n with 2 and find u2. And then u3, u4, u5. So what should those be? Try that now. Okay, hopefully you got 8, 13, 18, and 23. I'll just go over the first one here. 8, if you put a 2 in here and a 2 in here, you would get 5 times 2, which is 10, minus 2 is 8. And then for u3, you'd put a 3 in here, and then a 4 in here, 5 in here, and you should get all those terms. So there's your linear sequence. You should notice this is linear because when we find this first difference, basically, again, what that means is look at this one, and what's the difference between those two? How much does it go up by? Well, the difference is 5. 8 minus 3 is 5. It has to go up by 5. And here also by 5. And here also by 5. And here also by 5. So the difference, first difference, is 5, and it's constant. And whenever you see the first difference like that being constant, it tells you automatically it is a linear sequence, all right? If these numbers were different, it would not be linear. So let's look at this one. This one's written, it's the same thing, it's just written backwards, right? Here's your slope part. The part with the n is always your slope, the m, and the number that's alone without the n is always your y-intercept. So it's the same as y equals mx plus b, just backwards. So again, let's take a look. First, we're going to find u1. u1 is found by replacing this with 1, and then this is replaced with 1 because n is 1. So we have 3 minus 2 times 1, which is 1. So u1 is 1. That first term is 1. So now please fill in the other 4 terms here in this sequence, the next 4 terms. Right? Hopefully you got -1, -3, -5, and -7. And we get that by looking at this here. For example, u2, the second term, we would put a 2 in here and a 2 in here, and you'd have 3 minus 4, which is -1, and so on. So there's our sequence. Does this one have a first difference that's the same as well? Let's check. To go from 1 to -1, you go -2. To go from -1 to -3, you go -2. And so on and so on. All right, so again, this first difference, the first difference is constant. And if the first difference is constant, it tells you it must be linear. All right, that's like our slope. So now that's the important thing to note. These are linear because they have this common number here. And that common number appears here also, right? So this common first difference is our slope value here, the m value, the number by the n. Let's look at over here. Same thing. Yes. Here is our common first difference, -2, and that can be found here, -2, which is like our slope value. So the slope here is -2. This tells us our slope. This tells us our slope. All right. So now we take those and we plot them just to confirm that they're linear. All right. In the first one, u1, and this is our n value, right? So n value here is 1. When the n value is 1, the term is 3. When n value is 2, the term is 8. When the n value is 3, the term is 13, and so on. And 4 gives you 18, and position number 5, or n value of 5, gives us 23. And it's definitely linear. You can see it's making a line. And now I'm going to put 0 here. So u0, this is u1, but if we went back one term to the 0th term, it would be, notice these go up by 5, therefore this would go down by 5. So 3 minus 5 would be -2, and that's where this one is -2. And that's our y-intercept, right? So let's confirm that. There's our slope, which matches the first difference. And then there's our y-intercept here, the b value, -2, which matches our y-intercept here on the graph if we went backwards from the first term back one. Right, let's look on this one as well. At the first position, we have 1. At the second position and value of 2, we have -1. At the third position, we have -3. And at the fourth position, -5. And then -7 when n equals 5. At the fifth position, right here, definitely linear again. Let's jump back to 0 again, right? This is the first term, but if we had a 0 term right over here, that 0 term would be back from here. These go down by -2 every time. So if you go backwards, it should go up by -2. So it should be 3 here, right? And that's where it is right here, 3. So our y-intercept should be 3. Let's confirm all that. Here is our slope beside the n, -2. That slope matches the first difference, and that matches the slope on here, down 2 over 1, down 2 over 1. All right, and then we have this value, which is our y-intercept, our b value, and that should match our y-intercept here when we took this and moved it back one term to the 0 position. So I hope that all makes sense. That is the basics of linear sequences. We're going to do some key conclusions. One key conclusion is that for linear sequences, the difference between consecutive terms is constant. And again, that is this difference. This difference is constant. That's what tells us it's linear. So that's constant. And the explicit formula is then written like this. U sub n equals a, that's our y-intercept, plus we need our slope value, and we're going to use bn. So our general rule is a plus bn, and b is the first difference, right? That's that common difference, which is also the slope. All right, here's a sample for this general, find a general formula for the sequence. So here's a linear sequence. I'm going to take this sequence and fill it right in here. There it is, 11, 17, 23, 29. Now the first difference is up by 6, up by 6, up by 6. So this is common constant, so that's our slope. So now you see here, well, there it is, there's our slope. So I've already written here with a blank. We don't know what this part is, but we know the slope is 6, so that goes here. All right, so now we're going to use a technique which you might feel seems unnecessary right now, but we're going to use it because it's going to help us when we do more difficult ones in a couple days. All right, so basically I'm saying I know the slope is 6, so I know our rule must look like this, but the rule is missing a piece. But let's use what we know the rule must have. It must have 6n. We know there's going to be more to it, but let's try just 6n. Let's try pretend that it was just that, and what do we get? So when n is 1, and you put 1 in there, in 6n, you get 6, right? 1 goes in there, you get 6. But that's not 11. In our sequence, the first term, un, must be 11. But just using only this piece gives us 6. So we're not quite there. All right, now let's look at the second term. Second term is 17. So I'm going to input that second. See, un, second term, u2 is 17. But if we just put 2 into 6n, we get 12. So again, we're short of what we need. We need 17 to actually create the sequence we have. But just using this piece, without this, yeah, it gives us 12. Next one, 3. The third term is 23. So u3 is 23. But if we use just this rule, you do 3 times 6, you get 18. Again, we're short of what we need. And finally, last term is 29, and it's 24 there. So because if we put 4 in here, we get 24. So we're short every time. So just using 6n is not enough. We need something else in this rule. The rule is incomplete. How much are we short by every time? Well, here we got 6 using that, but it should be 11. So we're short by 5. Here we got 12, but it should be 17. We're short by 5 again. And if you notice, all the way through, we're short by 5 all the way through. So the missing piece must be 5, all right? And we've created the entire linear sequence, and we know this is our y-intercept value. So that's how you create a simple linear sequence. Again, we're using this kind of long approach here. You'll see why it's going to help us out with more difficult problems soon. So please try this one. Fill things in, and let's see how you do. Oh, yeah, first of all, this 23, this was a typo. 11 is wrong. It was copied from the last problem. This should be a 23 because that's the first term in this sequence. All right, so now try it out. Okay, so there's a sequence. There's the common difference. Our first difference is 14. That tells us that must be 14 for our slope. And we're going to put 14n there and 14, filling in the rest. All right, that means here's our sequence, but here's what 14n produces. It's short. It's short by how much every time? It looks like 9. So that means it must be our missing piece right there. Great, try one last one. This one again, this is a typo one more time. All right, so that should be the first term in the sequence, which is actually 16 right here. So replace that with 16. Now try to fill in the rest. All right, there's our sequence. Our common difference across here is -7, goes down 7 every time, -7. So that means that must be our slope value. So I'm going to put it in here as our slope. Now we're going to put -7 in here. We're going to see what -7 produces. So -7 times 1 is that. There's the actual sequence on top. And there's the what -7n produces. -7n doesn't produce the actual sequence. How much is it off by every time? Well, -14.9. That's off by 23. This is off by 23. This is off by 23. It's all off by 23, so that's the missing piece. All right, great job if you got that. We'll see you next time to try some things like this in class.